Alright, so in this video I'm sharing 3 different scripts. The first one's going to be the door, and this is a cluster, and what it is, it's all of the steps are in here. So this is the entire script, and I've organized it here at the beginning with the sliders for the inputs and then the components here for the outputs. So this is the door, this is the window, and this is the sliding door, and I've put them all within one script because this can be used as some blocks that you can use in your architectural designs. And so what you'll see down here is the door, which is here. Obviously this is set to 0.0, but we can change the size and all of the details here. What's cool is that we can set our own curve and change that location. So let me show you that. I'll take this line segment. It doesn't matter what length it is. We can set that as one curve. And then here, we can shift the location of that handle here. So this is the location. We can also change the size here. So the reason why this is useful is because let's say you're working on a floor plan and you've got your walls, you've got your configuration ready. This script can be used to add the door details in 3D and therefore helping you save a little bit of time. So that's what this is used for. Then if we look here in the window, you're going to see the same thing. This window, so now I'm going to go back and override it with the original parametric curve. I'll delete this. And so this is ready to be applied to any curve. Same thing with this window, but the window is a little bit different because we're actually using a surface. So now if I were to create a line segment here and extrude this up and use that surface, I'll go here to set one surface and override it. You'll see that the window will move locations. Now here, you'll see that it turns it into a horizontal or into a vertical slider, but we can change that here if we said slider on and then slider off here. The trim, you can have 2 different options, both fillet or chamfer, depending on what use you're trying to create here. And so let's go back and override it with our original parametric surface. So we can have this here and we can apply it to any surface. So let's go back to slider off, and it can create a fixed one as well. Now let's move on to the sliding glass door, which is very similar in the sense that we can change the length, but we can also set our own line segment. So let's say we have a door that's 12 foot. Now we can go to this one, set one curve, and override this curve into the extrude input. And notice that we can now change all of the details that we have here. We have, let's see here, the number of doors. And in the top view, if this is shifting out, well, we can shift the original door location. So here we're going to see door offset. And as long as your trim is wide enough to fit your doors, then you should be fine. Now, you can also increase all of these wall depth, and all of the details are very similar from one to the other. So I made sure to make them consistent. And so, like I said, this will serve as a really useful set of blocks and parametric components that you can use for your projects. So I'll delete this and override it with this line segment. So what I'll be doing in this video is sharing with you how to use these components and these clusters for your own designs. So what we need to do now is create an exhibit to place these into, and I will show you exactly how to do this. So to start, let's say you have a floor plan, and I'll be creating a box. So keeping it simple here, we'll go 30 foot by 30 foot. Now, the wall thickness Depending on which way we want those dimensions to stay, we can offset to the outside or to the inside. On this one, we'll go to offset by 0.5 to the inside. Then I'll go 0.25 again and 0.25 again to the outside. What that does is gives us the interior material, the wall, and the outside material. So now let's take these two and let's extrude them. So we'll go to extrude curve and let's go up by 12 feet. And do the same thing between this one and the wall. So extrude curve, making sure that it says solid. So we're creating our base geometry, which is the wall, interior, and exterior materials. The reason why I made this 0.5 and these two 0.25 is because that makes the outside wall 1 foot, and that makes it easier for us to change it here. Of course, depending on whatever size walls and assembly you have, you would actually vary this number. So let me show you here the next step. We're going to start by creating the front door. So the first thing we'll do is bring in a door opening. So I'll go to layer 1, go to a box, create it from the center. So this is modeled within Rhino. This is not parametric, although we can also create this parametrically. And now I'll go here to 4 foot, then 4 foot again, and then 10 feet. I'll do another opening centered here. Now nearest can cause some issues, so I'll turn that off for now. I'll go to centered, and then I'll go 12 foot, and then 10 foot. 12 foot, enter. Let's do that again. Box from the center, 12 foot, and then tall, 10 foot. And now we're going to create a window here and another one here. So what I'll do is I'll create a box, once again, centered, and I'll go and give it a dimension. So let's say for the sliding glass door or for this window, we're going to be making it 6 foot by 6 foot by 6 foot. Now I'll move this vertically and move it over by, let's say, 6 feet, maybe a little bit more, 8 foot, and mirror that one from the center to the other side. So these will be fixed windows, and then on this one, or maybe those are sliding glass doors, and then this one is going to be a bigger window. So a box centered from the midpoint, 12 foot, and then make it 10 foot tall. And then I'll extrude this surface down by 8 foot. So I've overlapped the walls in assembly here with those boxes. Now I'll select that and go to Boolean difference, which you can abbreviate with BD. Hit enter. And now make sure you have whichever option you have here on. I have delete input yes, because I want to get rid of those. And cutters, delete cutters no. So let me show you here. So it gets rid of the subtractions. And now we can create a door, sliding glass door, fixed windows, and a sliding windows and a fixed window. What we need to do now is tell Grasshopper how and where the doors are located. So if this is exactly in the middle, I can just create a line segment from the middle to the middle here. Same thing here. If we can, start on the left and end on the right. Same thing here. Now on this one, should be able to just create one and then copy the other one over. Same thing, this one. Okay, so now let's bring in our clusters here and let's start placing those where they're supposed to go and bake them one at a time. Now, I've already done this a few times, so what will show up are these 3 layers, and these 3 layers are, let's go here to delete. These 3 layers are created when you bake the objects using this component and you go to true, it's actually going to bake it to its own layer and layer name. SGD is abbreviation for sliding glass door, and then window. So all of these will be going into their own layer, and that's going to be useful for many things. One of them being keeping organized. So let's start with our first one. All right, so let's start with our door. So we'll take this line segment, we'll go here to our door, and let's set one curve. Now what I've done is you'll see an empty component in each and every one of these where you can place your own base geometry. In this case, it's going to be a line segment. Now this has been created. I'll go here to set one curve. Now you won't see anything happen until you override it here. And you'll see some of the details may not work yet because the wall depth, we know it's 1. The trim depth, we can change that as well. So let's make it 0.5. And if we want this door to be open or closed, we can also do that. We can have it closed, 90 degrees open, but now you have to change this, the hinge to that one. Or you can do -90 and keep that same location. So I personally like to keep it closed. I think this makes it easier for you to go in and almost manually rotate some of these depending on whether they're open or not. And in a 3D model, sometimes you do want it closed. So it really depends on your preference. So now that you see it here, we can't actually select it or click on it or do anything except for select that line segment. And so what we'll do is go here to the door. At the end here, double click on false to true, and then double click it again to turn it off. Why? Because if you leave it at true, any change you make to this, it's going to bake a completely new set. So now with this, you'll see that it's on this door layer and we can turn it on and off. Now let's move on to the sliding glass door. We'll go here, set one curve, and also once you bake it, then override it with the original one here. So you can use this and bring it into any 3D model and use it. So now this one, set one curve, same thing we did with the door, but now we're going to override this line segment. Let's look at the trim size, 0.5. Wall depth at 1. Frame depth. This one has to be at least a foot. Same with this one. Okay. All right, so let's focus on this one. We got that one. So now that that sliding glass door is there, we can double click, turn it on. Now we have SGD and door. Make sure to turn this off. And now let's move on to the next one. So let's take this line segment. Now for a window, we said it has to be a surface. So what I'll do is I'll extrude this curve and set this as one surface here and override the input. Now wall depth, we know it's 1. Frame 1, frame 2. Hiding this one. So notice that all of those are good for now. Double click on true and then turn it off. Now we have a new layer and it has all of these objects. So I'll select this and group it and copy it or mirror it relative to the midpoint. And override back to the original. All right, so now we got this big one. I'll take this line segment, extrude curve, and set this as one surface. Now, let's go back to override this and hide this input and change some of these components. So slider off and slider off makes it a fixed window. But if you want it to be vertical slider or horizontal slider, those options are there. And we can fill it or chamfer the edges here. And so if we look at it here in top view, all of these are very clean 3D models that have been programmed within Grasshopper to make it a lot easier for you. So now this last one, Boolean toggle to true and then off. Now we'll group this together and override the original. Now, here's the thing. All of these components and all of these scripts are based off of a foot units, right? It's not based off of inches. So what happens is, let's say you want the wall or the door to be 24 inches. Well, you can't just type in 24 because 24 is going to be 24 feet. So one way to account for that is using this component at the top, which is nothing more than just dividing by 12. So 2 divided by 12 equals 0.16, and 0.16 is 2 inches in feet. So you can use this component to plug in inches values. So let's say if you wanted the door trim to be exactly 7.5 inches, you can type in here 7.5 and use this as the input for that. So I'll save this. These are the 3 different ones that will help you create spaces like you see here. And I'll have that available on my website. It'll be available for a month. That's what I've been doing lately is I take my scripts that I create a whole month for and I share them for free so you can download them and, you know, follow along with the tutorials. And at the end of the month, I put them back behind a paywall to make it available for whoever goes into the membership. They're able to download not just these scripts, but all the scripts that I've done in the past. So that's kind of the idea of me trying to help as much as possible. If you have any questions, let me know. I will have this video and it will have all of the tutorials in a time lapse so you can see how all of these are made within one video. So hopefully you're excited to see how Grasshopper can be used for architecture and for practical uses, not just crazy things, to save you time, but also not just to save time, right? But also for you to be able to see all the options and be able to program your own components for your own projects. I think that's the sweet spot within parametric design is how can we use it in a practical way to save a bit of time and also to make sure that it's very accurate, clean, And we can move forward and look at other things like the design of the spaces. All right, so the first thing we'll do is bring in a parametric point so we can locate our line segment. So I'll go here to construct point, and this will give me a parametric point. I can also change the location of that point. Then I like to route it through a empty point component, and I'll plug that in so that way I can change that location if I want to. Now from that point, we're going to be creating a line segment that's going to represent the center line of our door. In this, we can use different things. We can move that point or use SDL, which will give us the start of a line segment, the direction, and the length. So the start is going to go here. The direction is going to go in the unit X, and the length is going to be whatever size door you have. So let's go 3.0. All right, now with this line segment, let's extrude it up. So I'll bring in an extrude component and also the vector in the direction that I want to extrude. So it's going to be up in the Z direction. And then copy this over and plug this both into the direction and into the base. All right, so we've got the door, and this is going to represent the surface of where the door is located. Now, when you're creating a script, you have to know what input you want to use, because that's going to determine how useful your script is. Now, if you want to plug in a curve to create a door, then we would actually use a curve component here to be able to override this curve component and plug in any other curve. Now, if you want to override the surface, let's say if you already have a surface in a model, then we can see if we can put a surface here. And so the entire script would be based off of this surface. So depending on what input you want to have, you would take a different approach. Now for me, I actually want to start with this line segment because the line segment represents the location on the floor. And then we know that we extrude this up. What happens is sometimes you will apply a surface that is not oriented the right way, and therefore the frame and the other things we're going to do may not work the same. So now that we know we're going to be using this curve, then we will use this curve coming out of this relay, which I did by just double clicking on the input or on the output, and that gives you a relay, which we could also delete. Okay, so now we're going to take this curve and offset it both ways. So we'll go to offset curve, and now we'll go to 0.250, and we'll offset that curve to the one side by 2.5. I like to create a relay because we're going to be copying this down. So I slide it and tap Alt. It's different if you have a Mac, by the way. And then negative in this direction because we're now offsetting from the center line of where the door is out to each side. Now what happens here is if it's 0.5 here, well, this is 0.5, which makes it 1, which means that this number needs to be divided by 2, which we can do here. So you're starting to see that we can interject anywhere and add relays, and this will make it a lot easier for us to add components and stuff like this. Also, it helps keep it organized. All right, so we got 0.3, half of 0.3, half of 0.3, making it 0.3, the whole thing. All right, so now that's going to be the depth of the wall. This is going to be the door height. This is going to be the length. And you'll see later on that we can plug in any curve and create the door on that curve. So we're working around this line segment. All right, So now that we have these two curves, now there are a few things we need to do. We need to get the endpoints, and we also need to expand this out here to create the frame. So there's different techniques that we can use for this, but I'm going to show you a really interesting one. First, we'll bring in the endpoints because we need to create a frame. So we'll do endpoints for one offset, endpoints for the other offset. Then we're going to extend both of these curves by the size of the frame. So 0.250. And notice that we'll do the exact same thing to both. So I'm sliding down, tapping Alt to create a copy, creating two extensions that will also have endpoints. I'm sliding it, tapping Alt, and extracting the endpoints. I'm just trying to keep this organized so you can see all the wires and how they connect. Now, we're going to connect the dots. So now we'll go to Polyline. We're only doing one side. We don't have to do the other side. So we'll go start point to start point. So this one, these two don't go together. It's that one to this one. Then to this one. And to this one. Notice it creates that polyline. Well, now, if we look at this polyline, it's a closed polyline. So we can disable the preview on all of this for now. And now we can offset this by whatever the frame size is going to be. So I'll copy this over. And now we need to turn these two into a solid. So to do that, I like to bring in the endpoints so I can close both the start and endpoints with a line, which will be represented by a line segment that starts at point A and ends at point B, but it has to be both the starting ones here and both of the ending ones here. So you're seeing that I'm going with the endpoints, and I'm joining all of this together using join curves. If we look here at the output, it says 2 values, so then we'll flatten it, making sure that it's only one polyline. Let's bring back that surface so we can see it clearly. All right, so what we need to do now is take this surface. We need to create a rail in which this frame goes around. So to do that, we need to deconstruct or explode this surface. When you explode it, you can pick one of these line segments. So when you have a 3D object, you usually have a surface, line segments, and points that create it. The points we're not going to use. We're going to use this line, and this line. So we'll start by list item. Actually, no, there's a better way to do this. And that is, let me show you. We're going to get the endpoints, and I'll explain why. Give me 1 second. Here's the reason why we want to do it this way. We want to create a line segment starting at the bottom, going up to the right and down. sometimes when you extrude this, the line segments might change. So now we need to take this and move this up by the same amount of the door height. So we'll go to move. We'll use the same vector as the door height because we want to move both of these points up. So we have a polyline that we can create starting here. And then moving up and around to create that frame. So we're starting with this point up and around. And now that line segment can be used to sweep this form all the way around. So now I'll go here to this one, and I'll turn it into a surface first. I'll go to boundary surfaces, and then I'll go to sweep one. This is going to be the rail, and this is going to be the section. So let's go here. And let's hide the input for some of these so we don't have all the wires going crazy. So let's look at this. The length changes, the height can change, and it's tied to the height here. The depth of the wall is going to determine the depth of the frame. Then if we move along, the extension is going to determine the trim size. And up here we have the depth of the trim, and the final result of the frame. All right, now let's create the door. So we've got the line segment here. If we were to offset this to each side, the same way that we did for the frame, but this time, when I bring this back, you'll see that it's been offset by that much. So we'll do 0.125. And since it's going to both sides, we know that this has to be divided by 2. Now we'll close it off using that same technique of bringing in the endpoints, connecting the start and end points, and joining it together. So the start and endpoints. Join together with these. So 1, 2, 3, and 4. I'll flatten the input. So now we've got this, and we've also got this frame here. Now we can take this, turn it into a surface. So we'll go to boundary surfaces. And we're going to take this and extrude this up. So we'll go to extrude up by the same amount as the door. Then we can take this and subtract it from the frame. So we'll go to solid difference between the door, which we want to keep, and subtract the frame, which will give us the result here. Now, the thing is that we need to have a spring point, which has to start down here, and this may not give us that result. So one thing that we need to do is then take these and get the extension. So extend this and this in the negative direction. So by the size of the trim, and let me show you what I mean. So the size of the trim is going to be the offset here. Now if we get the endpoints of this and this, we can pick which one of those points is going to be the one to rotate. So if we go to list item and we plug both of these in and flatten it, now it's going to only pick one, and now we can go between 0 less than 3. And now we can route through the first one, second one, third one, and fourth one. And that can be used for this. The result of this, which we can hide some of these wires, we can rotate relative to that point. So if we use this point as a plane input, this one as the geometry, we can bring in a slider. We'll say less than 45, less than 45, less than 90. Notice that that's the wrong point because it's picking that one over there. So then you do have to change this to be the correct number that it rotates. So at this point, we have most of the stuff that we need. The only thing that we don't have is going to be the door detail. So let's change that. If we go back to these that we extended, and we even go back to this being 0, now I want to extrude what I extended here, but I'm going to do both. Let's see, this one, the front and the back. Now we need to offset, so we'll do it to 1 because the other one is going to be the opposite direction. So first things first is we need a direction in which this is going to be extruded. So we'll evaluate surface, reparameterize. The point is going to be at 0.5 in the X and 0.5 in the Y, which is exactly in the middle. Now we're going to take this and offset it. Offset curve, using this frame as a plane, and B-rep edges and joining the naked curves. Now it's offsetting to the outside, so we'll bring in a negative and offset to the inside. And now between these two, I can create a surface. So boundary surfaces between this and this. But notice they overlap unless you bring in this graphed tree component, which will make it so they're organized correctly. And now we can extrude relative to this frame. So extrude. Direction, well, it's going to be in perpendicular to the frame, or it could be off of the normal. The amplitude is going to be by how much. So we'll do 0.125. Now here's what happened is that the extrusion of this is past the frame. So now we need to subtract this. The height of this, subtract by the frame, which is here. And it has to be a vector, so you can add the vector. We'll hide the input on this, and we'll subtract the vector. Now this can be the number to extrude this. Notice that it shortened it because it extended it back down to where it was supposed to be. And same thing with this one. All right, so we'll do the exact same thing, but this time we'll also, let's see, we'll bring this up. Now we're going to copy this and do the same thing to both the top and the bottom, but this one is going to be negative. So let's do it. Let's hide this and let's put together the door between these two and the door this one. That's the frame. And that's the door. Okay, so now we need to put together both this one and these two. So I'll go to union or solid union. We'll go this one, and this one. And then merge. Coplanar faces so we can see things clearly here. So now notice that this is our door. Now we need to go back and bring back our frame. And let's see here. Now we can rotate this. So we're moving this over because now this is what's going to be rotated. Right now it's rotated by 0, so it's obviously staying in the same location. And now we'll hide the wires on this so we can rotate it and show it. Okay. So now let's take it let's let's organize it. So I'll go here to an empty geometry component, bring that in, hide the wire display to hidden, then the door to this one. So we have these two. And now technically, since we've taken the outputs and simplified them into these two components, we can disable the preview on most of this stuff. And so we can see it a little bit better. Then I'll bring in a custom preview with a material, which is going to be a color picker. And when we plug those in, I do like to hide the wire on this one. This one will be a little bit darker, and then the door will be down here, which we can change to maybe a darker green or something like this for now. So let's look at all the components. Door length, door height. This is going to be the depth of the door, so 0.1. Then door frame, trim size. And I'm grouping that one. And then this one is going to be 0.1. Door trim depth. Door swing load. This one is the door trim depth, so 0.05, and then the door frame offset. Now, a lot of these names are just subjective, right? Like it's just what I think that they should be called. Now, there could be more technical or more precise terms for whatever script you're making, and that's what's cool about creating a script, is that you're kind of in charge of what direction you want to take things. So this angle of rotation, we can also change this. We can even go -90. Now here's the thing, if we go like this, this is going to be the door swing location. So notice that depending on where you want it, you might have a different approach. Now this one, if it goes in like that, that's incorrect. So then here you can almost say -90, in the sense that you can also swing it the other way, this way, and then if that's not it, then that's it. So what's useful about this, let me show you. If I took this line segment and I created it here like this, not even aligned, let's check and see if this works. Because this is kind of the point of the parametric script, right? If I set this curve and I plug it in, does it still work? And it does. So we can change the size of this to be whatever we want. You can have them within a floor plan, and then just go back here and bake it. Now, this is more of an exercise one. I have two other versions that I'm sharing with you. I'm going to have the video script, which is this one. Then we're going to have another script, which is going to be the other one that I created in the initial work session. And then the last one is going to be the cluster, which is the simplified version of all of these. So if you want to download it, go to my website, capettidavid.com. There you can download this and other resources that can help you. Hopefully you learned something from this. You're excited to, move forward with your parametric skills. And I hope to see you on the next one.